Okay, so the first question is we're solving. So we need to find the value of the variable, and in most of these it's going to be theta. And here we've got it between 0 and 360. So just going to do this up here. I know that it's root 3 over 2. That's an exact value. So root 3 to 1, so that's 60 degrees, 30 degrees. I'm just going to put the radians there as well. That's pi over 6, that's pi over 3. So we're going to use some exact values. So if its sine is root 3 over 2, that's sine of 60. So we know that sine of 60 degrees is root 3 over 2. So looking at stations to central, we need this angle here and this angle here. So we need to go all the way through one revolution. And the top two quadrants are positive. So therefore theta equals 60 degrees, or it's 120 degrees. It's in the second quadrant. Now in part 2, the first thing to realise is we're working in radians. So make sure your answer is in radians. Now we've got a half this time, but it's negative. So looking back at our our exact values, it's going to be this angle here, the 30 degrees, that will give us sine of a half. So it's going to be pi over 6. So we know that sine of pi over 6 equals a half. Now the thing to realise is we have 2 theta, sorry. So and we need our angles between minus pi and pi. But because it's 2 theta, we're going to find 2 theta between minus 2 pi and 2 pi. So what that means is, let's do it this way. Instead of just going to pi, we're going this way. So that's to 2 pi. So we want all the answers down here because we want the negative answers. So we know that the acute angle is pi over 6. So this and this. So let's do the first lot of answers. We know that 2 pi is going to be pi minus pi over 6. That's this one here. We know it's going to be 2 pi minus pi over 6. That's this one here. Now we need to go and do the ones in the negative direction. So these ones, and we need to go all the way around to minus 2 pi. So we've got this one and this one. So we know that it is minus pi over 6 and minus 5 pi over 6. So 2 theta equals that one. The first one will be, it's plus 7 pi over 6. This will be 11 pi over 6 minus pi over 6 minus 5 pi over 6. Now we've got to divide everything by 2. So all the denominators are going to become over 12. And all of those answers now lie between negative pi and pi. And there's 4 possible answers. Okay, this question here, question C, is a quadratic that we need to solve. So we're looking for 2 numbers that will multiply to give us minus 4, but add to give us 3. So I'm going for 4 and minus 1. What I do with that information is I'm going to split this centre term into those two. Then I'm going to pair and factorise. So 2 cos squared theta plus 4 cos theta minus cos theta minus 2 equals 0. Now I'm going to factorise this. I'm going to take out 2 cos theta. I'll have cos theta plus 2. I'm going to take minus 1 out of that and have cos theta plus 2. Now I'm going to factorise this, so the common bracket and then the other stuff. Now I use the null law. Two things multiply to give me 0. So therefore cos of theta plus 2 equals 0, or 2 cos theta minus 1 equals 0. So cos theta equals minus 2, or cos theta equals a half. This first answer is not valid. Okay, so we're going to look at this one here. I need all the answers between 0 and 2 pi. So I need this answer here and this answer here because my answer is positive. I know that cos of 30 is a half, or pi over 3. So that tells me that theta equals pi over 3. That's my answer in the first quadrant. Or this one here is 5 pi over 3. Okay, question D. This one here is a Pythagorean trig identity. I know that because I've got cos squared and sine squared. My aim is to get them so I only have either cos or sine. I'm going to get rid of the sine squared. So this will become 5 cos squared theta equals 3 minus 3. Outside of 1 minus cos squared theta. So expanding, plus 3 cos squared theta. Now I have an equation with only one variable. I've only got cos, so now I can solve and find what theta is. Now 3 minus 3 is 0, so I've got 5 cos squared theta equals 3 cos squared theta. Now I'm going to minus the 3 cos squared off each side. So I'll have 2 cos squared theta equals 0. Divide by 2, cos squared theta equals 0. Take the square root. Cos theta equals 0. Now, I'm looking for all the angles between 0 and 2 pi, where cos is 0. So that's there and here. So theta equals pi over 2 or 3 pi over 2 because I'm working in radians.